The glint of gold under the arena lights, held high by a bloodied and exhausted champion, represents a moment of triumph witnessed by millions. It is the culmination of years of sacrifice, a narrative of struggle and victory crystallized into a tangible object. But what the cameras never capture, what the production trucks parked outside the stadium never transmit, is the journey of that object before it ever steps into the spotlight, before it is raised in victory, before it is kissed by a legend or worn to the ring by a titan of the industry. It is a concept on a secure server, a block of raw metal, and a problem to be solved by engineers operating far from the roar of the crowd. This is the hidden world of championship belt fabrication, a process that marries old-world jewelcraft with the cold precision of modern automation. Within workshops that resemble a cross between a fine jeweler's atelier and a high-security manufacturing plant, raw materials undergo a radical transformation that borders on alchemy. Most fans will never see the scale of the operation required to produce these symbols of supremacy, the industrial choreography that turns zinc, copper, steel, and leather into objects of desire worth tens of thousands of dollars, revered by audiences from the packed arenas of Chicago to the living rooms of London, Sydney, and Toronto. We are granted rare access to the facilities where secrecy is as tight as the quality control, pulling back the curtain on a system designed for precision, speed, and durability. If you have ever wondered how a simple ingot becomes a legacy, how a sketch on a napkin evolves into the icon held by the likes of Stone Cold Steve Austin or The Rock, you are about to find out. To continue gaining access to these hidden industrial worlds and to see how ordinary objects are transformed into icons, please like this video and subscribe to the channel for more deep dives into the factories and foundries that power our entertainment and our modern world. The journey of a championship belt begins not with a hammer, but with a hard drive. Long before any metal is cast or any leather is cut, the belt exists as pure data. Deep within the design wings of the manufacturing hubs, often located in specialized industrial clusters like the famed city of Sialkot in Pakistan, renowned for its precision hand-stitched leather goods, or the high-tech manufacturing zones of Guangdong in China. The creative team works in tandem with digital rendering tools to produce blueprints of exacting detail. Every curve of the plates, the exact curvature required to fit around a human torso, every facet of a gemstone holder, and the precise depth of the lettering is mapped out in 3 dimensions on screens displaying resolutions down to fractions of a millimeter. The design phase is a collaboration between the belt maker and the licensing entities, ensuring that every logo, every star, and every stripe meets the strict brand guidelines of the promotion. Once the design is locked and approved, sometimes by legal teams thousands of miles away, the industrial scale of the operation reveals itself. These are not small craft shops tucked away on side streets. They are vertically integrated facilities where die-cast metal stamping machines, capable of exerting hundreds of tons of pressure, stand ready alongside 5-axis CNC engraving systems that can carve metal with the precision of a surgeon's scalpel. The workflow is a study in synchronized efficiency, a ballet of logistics and timing. On one end of the warehouse, rolls of top-grain leather or high-grade synthetic materials are laid out on vast cutting tables. Here, automated presses, guided by the digital patterns from the design phase, stamp out the strap shapes with a single, decisive blow. There is no room for guesswork. Every strap is identical to the last, ensuring consistency across hundreds of units. Simultaneously, in the metalwork foundry, a separate wing of the facility entirely due to the heat and safety protocols, large batches of the base alloy are being prepared. While the final plating might be gold or silver, the core of the belt plates is typically a zinc alloy, prized for its casting fluidity and strength, or a brass alloy for higher-end replicas. These metals are heated to precise temperatures, monitored by thermocouples that feed data back to a central control room. The coordination is seamless. As the leather straps move down the line to be skived, folded, and stitched by a combination of industrial sewing machines and skilled hands, the molten metal is being forced into steel molds under high pressure to form the center plates and side plates. This integration of processes, collapsing what used to be weeks of shipping time between suppliers, cuts production lead times by up to 40% compared to fragmented supply chains. This efficiency allows the factory to output thousands of units per month, from standard replica belts sold in merchandise stores to the high-complexity, fully jewel-encrusted custom commissions destined for private collectors or historic milestones. In the heart of the production floor, where the air hums with electricity and the scent of ozone and cutting oil mingles, the human hand meets the machine with a fascinating and necessary synergy. While the initial die casting provides the rough shape of the plates, saving countless hours of hand carving, it is the CNC routers and robotic arms that bring the microscopic precision required for a world-class product. These machines, guided relentlessly by the digital blueprints generated weeks earlier, carve the intricate details into the metal, the folds of a flag, the texture of an eagle's feather, the sharp edges of the block lettering spelling out World Heavyweight Champion. It is a mesmerizing demonstration of automation's raw power, yet it is far from a lights-out, unmanned operation. Skilled technicians, often with backgrounds in toolmaking or precision engineering, hover nearby like parents watching their children take their first steps. Their eyes, trained over years of experience, are tuned to spot the slightest deviation, a tool bit that is beginning to wear, a surface finish that is not quite perfect. The relationship between man and machine is symbiotic. Robotic arms programmed for repetitive precision transfer heavy plates from the stamping station to the grinding wheels for deburring, moving with a speed and consistency no human could sustain over an 8-hour shift. These robots eliminate the ergonomic strain on workers while increasing throughput. Sensors integrated into the conveyor line constantly measure the thickness and profile of the plates, using lasers to create a 3D point cloud of every piece. This data is fed into a central monitoring system that flags any piece that falls outside a tolerance of a few microns, far thinner than a human hair. If a fault is detected at any stage, a microfracture in the casting invisible to the naked eye, an air bubble that disrupted the flow of metal in the mold, or a slight variance in the CNC engraving, the system automatically shunts the defective piece aside onto a rejection conveyor. This prevents the flawed component from wasting valuable labor and machine time further down the line. This intricate human-machine collaboration ensures that the massive scale of production does not come at the cost of the individuality and quality each belt requires. The machine provides the speed and consistency, the human provides the judgment and the final aesthetic approval. Precision in this environment is not merely about making the belt look good for a magazine close-up. It is a matter of rigorous risk management and stark financial discipline. A single error in the electroplating phase can destroy thousands of dollars in inventory in a matter of minutes, turning a batch of dozens of nearly finished belts into scrap metal. The electroplating lines, where the zinc alloy plates are submerged in a carefully choreographed sequence of chemical tanks containing gold, silver, copper, or rhodium solutions, are the most volatile part of the factory. These processes are monitored by AI-driven systems that track the chemical balance of the baths in real time, measuring pH, temperature, and metal ion concentration. If the gold concentration in a tank falls too low, the plating will be thin, porous, and prone to chipping the first time it is raised in a celebration. If the electrical current applied during the plating process is too high, the finish could bubble, discolor, or develop a rough texture called burning. The factories employ extensive redundancy to mitigate these risks. Backup power systems, often including massive battery banks and diesel generators, ensure that the delicate chemical processes are not interrupted by a grid fluctuation, which could leave a batch of plates half-plated and ruined. Automated shutdown protocols are programmed to halt the entire plating line immediately if a single temperature sensor reads outside the acceptable range, preventing a cascade of failures. But the machines do not hold the final authority. Quality control inspectors working in a lab adjacent to the production floor pull random samples from each batch. They subject the plating to adhesion tests, scratching the surface with calibrated tools to ensure the gold is properly bonded. They put the leather under UV exposure tests to ensure it will not fade under the intense lights of an arena. They even simulate the wear and tear of a match, flexing the straps and testing the snaps thousands of times using custom-built testing rigs. The cost of failure in this industry is staggering. A delayed shipment of a championship title for a major televised event like WrestleMania or a major pay-per-view in the UK can mean broken contracts, six-figure penalties, and a catastrophic loss of credibility for the manufacturer. Therefore, the extreme discipline enforced by these redundant, automated systems and the watchful eyes of human inspectors is the invisible backbone of the industry, the silent guarantee that the belt will perform when the world is watching. Behind the scenes, away from the assembly lines, visible to the occasional official tour or documentary crew, lie the proprietary secrets of the trade. These are the closely guarded techniques that separate a cheap souvenir from a museum-grade replica. In these secured zones, often accessible only via keycard or biometric scan, master craftsmen apply techniques passed down through generations of metalworkers, adapted for the demands of the modern era. It is here that the painstaking process of enamel filling takes place, a delicate operation where liquid glass, mixed to a specific Pantone color, is carefully injected by hand using fine syringes into the recessed areas of the plates. This creates the vibrant, durable color contrast that will not fade, chip, or peel under the hot stage lights. Another closely guarded secret is the method of applying simulated jewels. While lower-end belts use plastic stones glued into place, the high-end factories use a technique called setting, where the metal of the plate is actually raised and bent over the edges of a crystal, locking it in place permanently. These areas of the factory operate on a continuous cycle, often running 24 hours a day in rotating shifts to meet the relentless global demand. Invisible to the end user is the sophisticated energy management that keeps these factories efficient. Waste heat from the foundry furnaces is recirculated to warm the drying rooms where the leather straps cure. Water used in the rinsing tanks of the electroplating line is filtered through massive reverse osmosis systems and then recycled, reducing the factory's water footprint and operational costs. AI supervision extends to the logistics floor, where computer vision systems verify that the correct side plates are matched to the correct center plates before final assembly, preventing a costly mix-up that could send a Roman Reigns replica to a client expecting a classic big gold belt design. As the belts enter the final stages of assembly, the cacophony of the factory floor gives way to the quiet intensity of a watchmaking atelier. The gleaming plates, now fully plated, enameled, and jewel set, are carefully laid out on soft padded workstations by workers wearing gloves to prevent leaving any fingerprint oils. Here, the human touch becomes paramount once more. Technicians working with precisely calibrated, torque-controlled screwdrivers attach the plates to the prepared leather straps. These screwdrivers are set to apply exactly the right amount of force, enough to hold the plate securely, but not so much that they strip the threading. Before the final screw is tightened, however, the belt passes through one last gauntlet of verification. It is placed onto a conveyor that carries it into an automated inspection station. Here, high-resolution cameras scan every square inch of the plates, comparing the images against the original 3D render to check for scratches, plating inconsistencies, or the slightest misalignment of the snap fasteners. The snaps themselves are tested by robotic actuators that connect and disconnect them hundreds of times in rapid succession, ensuring durability. Packaging is executed with efficiency. The belts are carefully placed into custom-cut foam inserts that cradle them perfectly, preventing movement during transit. The boxes are then automatically weighed, measured, and sorted by an automated system that directs each to the correct shipping lane. Priority air freight for titles needed in the United States, or sea freight for bulk shipments to retail stores in Canada and Australia. A belt that fails the final automated inspection is not sent back for rework. It is immediately removed to be stripped down and recycled, ensuring that only absolutely perfect specimens ever leave the building. When we see a championship belt hanging on the shoulder of a superstar, we see glory. But now, the image is layered with a deeper understanding of what it took to get there. We see the thousands of tons of pressure from the stamping presses, the precise chemical reactions in the plating tanks, and the millions of lines of code silently running through the CNC machines. The belt is no longer just a prop. It is a testament to the quiet, massive systems that operate just beyond the curtain of our perception. In these factories hidden in plain sight across the globe, engineers and artisans work in concert with robotic arms and conveyor belts to maintain a standard of excellence that the world takes for granted. They are the unseen architects of victory, the silent partners in every title reign. We would like to know what you think about this hidden process. Does knowing how it is made change how you view the championship when it appears on your screen? Share your opinion in the comments below, and let us know which factory process or hidden industrial world we should explore next.